we will start.
Sure, no problem. Okay.
Hello everyone. I hope you can hear the voice okay, and you can see the slides. Today we have a very interesting topic about the Internet of Intelligent Things from Dr. Rabie Ramadan. Dr. Ramadan is associated with Computer Engineering Department at Cairo University, and currently he is on leave at the University of Hail in Saudi Arabia. He's a graduate of Southern Methodist University, and his field of expertise is in mobile computing, sensor networks, Internet of Things, and computational intelligence. Dr. Ramadan is the author of more than 125 articles published in respected journals and conferences. He used to work at Bank of America Securities Company in Frisco, Dallas, Texas, as a senior developer and researcher. He's the co-founder of the IEEE Computational Intelligence Egypt chapter. Currently, he is serving as the chapter secretary. Also, he is one of the co-founders or the founders of Fab Lab and Center of Programming and Electronic Applications at Hail University. The laboratory is sponsored by Saudi Arabia Ministry of Education. Moreover, he is one of the founders of Triple Tech Expert House, sponsored by Hail University. I leave the mic to you, Doctor.
Thank you so much. I appreciate your introduction. So, welcome everybody. It's my pleasure to be with you today. I'll be talking about the Internet of Intelligent Things. Actually, we're trying to answer how intelligence make the Internet of Things meaningful. So, I hope this presentation will be okay. We'll go on screen. So this is the table of contents. We'll start by introduction. Then we'll talk about the IoT applications, some of the applications, then some of the challenges and opportunities. Then we'll look at the intelligent IoT. We conclude after all. So basically, if we ask ourselves, if you lose something like your keys, nowadays you go Google and ask Google, where is my keys? So I did this. I lost my keys. I went to Google and asked Google, where is my? Then I stopped there. I found that Google came up with different words: keys, phone, mind, location, IP, home, iPhone, train, and so on. So Google almost knows everything about our lives. So I went further and asked Google about where is my phone. So he just came up with some different links that guide me to find my phone. So this is actually a part of artificial intelligence. Also, if you want to follow your child all the time, there is some application to do so using GPS tracker to find your child or kid and follow him. I mean, track every step he or she is doing. However, our children are more smart than that, so they can block us. There's another application like Julia, which is a home service robot. This robot is designed to help elderly people, that we can handle some. It works as assistance at home for elderly people. Well, so these stories or those applications, it's part of Internet of Things. But the Internet of Things starts at 2010 almost. Before that time, starting from 1990s to 2010, there was another term called Internet of People. where there were some computers and some phones. People can just communicate using voice. At this interval of time, we call it Internet of People. However, after that, things became more than 10 billions, or expected to be more than 10 billions in 2020, and things are communicating to each other. Yes?
The slides again, please.
The slides is in front of the screen. I'll reshare it again. Okay. Slides. Is this okay right now?
The slides are okay now.
Okay, thank you. So I was saying that by 2010s, from 2010s to 2020s, the term Internet becomes emerging, where devices are now connected to each other. Not only devices, equipments from around the world are connected to each other. So that's where the term Internet of Things came to play. So if we define Internet of Things, we can define the Internet of Things as the network of physical objects. Those objects could be devices, vehicles, buildings, and other items embedded with electronic software, sensors, and network connectivity. So those objects need to be connected, and where they are connected, they collect data and collect and exchange different data. The first conference on Internet of Things was actually was in 2008 and held in Zurich in Germany. So the term Internet of Things is not alone, or under the umbrella of Internet of Things there are different concepts like the machine-to-machine, the Internet of Everything, and this term coined by Cisco Systems is not, it doesn't go that far. Also, the Pros in the IBM Chief Technology Officer came with another term called World Size Web. There's another term came from the Terminator movie called Skynet. So all of these concepts fall under the umbrella of Internet of Things. So if we hear one of these terms, it's actually part of the Internet of Things. However, if we look at the Internet of Things, there are some drivers behind it. The first driver behind the Internet of Things is the wireless technology. Like the silver and Wi-Fi.
بتكلم واحد اسمه ربيع بتكلم عن internet.
However, I can hear you. Please, can you mute your microphone? So the drivers of IoT, the first driver of IoT is the satellite, the cell phone, the wireless technology, basically. The second driver of the IoT, the microcontrollers, the microcontroller prices and performance, where we have small devices like Arduino, Raspberry Pis, and different devices, different microcontrollers. Their prices, they are cheap prices, and their performance are well notified. Another driver of IoT is the sensor enhancement or the sensor advancement. Well, there is a project led by MIT called SmartDust. The guys are working on tiny sensor that, like the dust, so you don't feel it. It will spread on the environment around you. You don't feel it, but it collects information about you. So this is a good project. Still working on it. It's still developing. Also, as we can see that the cloud-based software and infrastructure is advanced. Cloud-based software enable the IoT. We'll come to this point in a bit. Also, the application development, if you look at the software development like the apps on the mobile devices, maybe desktop, the websites and stuff like that, the application development is also emerging that enable the IoT to be in place. So those are the IoT drivers, but there is one key driver to the IoT, which is the business. So when you find a business, everybody will go there. So in business, there's 14.4 trillion net profit for coming to the case, expected in the coming to the case. As you know, in the old days, $100 can be turned to $600 if you turn it to a smart device or smartphone, for example. So the old device for $100 is now sold by $600 because just the connectivity, just connecting the internet to it, it leads to increasing its price. So there's a potential or a business behind the IoT. Also, IoT markets from the devices themselves. Like, for example, 2013, there were 9.1 billion IoT units. Those numbers are expected to grow to 28.1 billion IoT devices by 2020. So this big market leads to, or a key driver to the IoT. In the United States, by itself alone, the market value in billions is 1.7 in 2019. So this is a big market for IoT. So if we summarize the drivers of IoT in general, we can say one first thing is the improved performance. The second is the cost, reduced cost. The third is a business or new revenue stream. Also the innovative services around either in the cloud or in mobile applications. So those are the drivers of IoT. But the question now is, where is IoT? Well, IoT, I call it's everywhere. So in our homes, in our offices, universities, and so on. And this figure is a great figure, actually. It explains the machine-to-machine world of connected services under the umbrella of Internet of Things. So if you look at the inside circle, you can see the service sectors, and it's almost every sector we know, like the buildings, the energy, the consumer home, the healthcare, industrial, and so on, transportation. So in each of these sectors, there are some group of applications, and the figure shows where are those locations and the devices that are used for such applications. So this figure actually it's a good figure to that shows how large the market of IoT, how large the research of IoT. So this is one of the good figures for IoT. Also, answering the question where is IoT, I can say that's another application like the home automation. But I don't like the term home automation. I like to say smart home, where not only automate, because the term automation leads to just controlling devices like actuators and sensors. But if we are talking about the IoT, we are talking about adding intelligence to those devices and actuators. So not only controlling the devices, but also adding some intelligence to it, to those devices. So for smart homes, we can say that we can control the light, the speakers, the window shades, the lamps, the TV, tablets, thermostats, and so on, even the garage and doors and front cameras and so on. So those is basically another application of IoT. Another application of IoT is the shopping. So for example, when you enter the door for a market, the scanner will identify the tag in your clothes and identify you. Then, when shopping on the market, the goods will produce themselves. So if you stop in front of one of the items, it just speaks to you and tell some information about it. Then when moving the goods when moving one of the items, the reader will tell the staff to get someone new to put it in as a replacement. Also, when paying for the good, just use a credit card to communicate with the checkout reader, and so on. So this is another application of IoT. Another scenario for the IoT is the healthcare. It's actually a big market for IoT, where everything you do about your health, or everything about the person's health, will go directly to the hospital and manipulate it over there. Yes, there are some issues like the privacy and stuff like that, but it's a big resource and actually big money over there in the healthcare. So this is another application. Well, one more application is the transportation, IoT in the transportation. Well, the transportation here includes fleets, vehicles, and drivers, the 3 items. And those 3 items, there are many of the sensors in the vehicle or with the driver. And these sensors will collect the data, but they collect specific parameters or key attributes like the location, the vehicle matrices, driver behavior, the hour and miles driven, and so on. Then these data will be transmitted for processing to a secure data center. It could be a cloud, as we mentioned before. Then the information after the analysis will be browsed or displayed for the customers like us, the one who want to control or see the buses or the drivers, monitor them. So this is another application, but there are a few other applications like the smart egg tray. It is called Egg Minder. The Egg Minder is just synchronized with the smartphone. It tells you how many eggs are still in the tray and how many and when it is expected to be going bad. So this is another application. There is a smart washing machine, and this is good for female. That's a smart washing machine. We already have a smart washing machine at home with fuzzy controller in it, but this is a little bit different. They can control the washing machine remotely and actually through the mobile. There's another application like the smart cooker, slow cooker, another good application that you can enjoy controlling the cooker, controlling all of its functions before even going home. There's another smart lighting application. Well, this is not just controlling the light. It actually controls the colors of the light itself. So you can choose, as in the photo, you can choose one of the colors, or you can choose a combination of colors to be displayed or to be lightened as a light for you. So there's another application which is a smart EC. It is not only controlling the EC. Actually, it is a smart controller. Where a smart controller when you can automatically maintain the perfect temperature, and also it looks at your budget, it looks at your usage and the schedule, and it basically controls the EC based on all of these parameters. So there is not only there is some intelligence behind this device. Moving on to another application, which is called the smart sleep system. Well, the smart sleep system is the system that monitors your sleep cycle and to understand what wakes you up, compare the nights, and by the end, it organizes your sleep system and also gives you some information about it. There's, of course, a weather station. It is a smart weather station. It's called Itamu weather station. And it gives you all of the information you need about the weather, like the CO2 and relative humidity and so on. So you can live in a healthier home. There's what's called Big Belly. Big Belly is just a garbage can, a smart garbage can, where it notifies you when the garbage is already full, so you can empty it. There's another gardening, smart gardening. It's called Bitponics. This gardening, it notifies you when there's a need for watering and doing something with the garden. So this is another smart application. Don't forget the three assistants, like the Google Assistant, the Siri, the Amazon Alexa. Those are parts actually of IoT as well, because you can communicate with them. So those are three assistants that could be considered as IoT assistants. To summarize the applications of the IoT, this figure shows that there are different types of applications like industry, agriculture, transportation, smart home, security, healthcare, and so on. So the information collected through sensors will be transferred wirelessly to a device. It says that it goes to a sync node. And this term, actually sync node, is used mainly with sensor networks. Some of the technologies, like the mobile computing, we call it a centralized node. However, the sync node, we use it only in sensor networks. The sync node is part of the system, is a node that collects the data. Sometimes it makes some analysis, and sometimes it's just a gateway in the middle. It transfers the information. So here, consider the sync node as a transmitter to another gateway. We call it mesh gateway. Then from there to the internet, then to the cloud server. So here, this figure, the one thing about this figure is it is the communication between the sensors and the cloud server. So these are the cloud servers, as part of the IoT. And there's one term called, research is going on the term of offloading. Offloading means that you try to do some computation on the IoT devices. But IoT devices are tiny devices, and maybe the computational power is not that enough. So what you do is you do offloading on the cloud server. However, there is a problem in offloading. When you study these tiny devices, or if you have a background in wireless sensor network, we say that doing 1,000 computation, processing, 1,000 process on a single device, IoT device, it is worth a 1 pi transfer for 1 meter. That means that the communication is costly. So what you do, when you do offloading, actually you are transferring, you are sending data to the cloud server. So that costs a lot from the IoT devices energy. So the offloading term, this is the big issue, or the offloading in general is a big issue in IoT. So there are some research on this area, and if somebody is interested, you can look at this. I like this figure, which is, it's called IoT domain tree. IoT domain tree, it just choose the domains that used with IoT. For example, RFID system, oriented architecture, and so on. That's all of the domains used by IoT, the healthcare and stuff like that. And underneath each domain, it shows either the application or the the parameters used for this. So this is another figure summarizes the IoT domain. Let's look at, since we talked about the applications and of IoT, let's look at some of the IoT products and platforms. IoT products, there are many products for IoT, but those are simple, like the Nest thermostat. There's cardiac monitor, it's called Corvent. There is window remote. There's attractive bed tracker. Somebody turned out the microphones. Okay. There's Lynx Cloud Platform. There's what is called ThinkWorks. There is Revolve Home Automation. There's Ninja Blocks and so on. So those are some of the IoT products and some of the platforms. Let's look at some of them in details. So, for example, Nest thermostat. This is part of the heating and cooling system. It is used to help to keep an eye on your apartment or your house. It can go wirelessly, it can go online, so it notifies you if there is something wrong with your home. So this is one of the thermostats, smart thermostat. There is Corvent, that's some cardiac monitor, because it's a patient term or health term. That's actually this device. It is a wireless device that monitors every physical activity you do and report to that. There is another device, we call it Ninja Blocks. Ninja Blocks is associated with software as well. It's called Ninja Sphere, and it is a hardware and software. This Ninja Sphere, you can connect to that. I can hear this, so if somebody enable the microphone. Somebody on the microphone. Okay. So Ninja Blocks is one of the smart devices, like the control. If you leave any devices on, so you give you a notification and you can turn it off right away. There are some trackers like the bits and people in cars, and we're already working on a project like this on the tracking, but actually we're tracking the autism and Alzheimer people. So we had a device, we use this we are building a smart device at our lab to track the people with autism and Alzheimer, and we are doing this for one of the companies. So this is another controlling device or device, smart device that's connected to the IoT. There is what is called Wemo Remote, actually, that you can control the device. That, as you see from the device, you plug in something in it, then you can control it directly from outside or from your mobile, Android or iOS. There's another project that we are working on. It's called knee stiffness. The idea of this proposal or this project, as you know, when you have a knee stiffness, and it reaches a moment or a time that you need to replace a joint, the whole joint. After replacing the joint, what you do, every time you go to the doctor, it just get you into the X-ray to check on the new knee. the new joint, the replacement one. And this is actually dangerous, and it is not actually avoidable. So the project that we are working on is to put a smart wireless device inside along with the joint itself. Then we can monitor every parameter that the doctors need, and instead of just going to X-ray every time, just I get the reader and I communicate to the knee. I communicate to the inside joints and get all of the information that we need. So this is another project that we are working on, and this is related also to, well, the information we get, it could be wirelessly, it could be deployed in a mobile, it could be deployed in a website, whatever, but this is part of the IoT. So if we look at what we saw right now, we can divide the smartness into 4 levels. The first level is the passive level. That means the communication only when required, like the RFID, the QR codes, and so on. So those are passive. There is another type of smartness, which is the active. Active, that means we communicate when needed, like the sensors, home automations, and so on. There's the third level is aware. That means the action will be taken based on a simple computation, like the telehealth. The fourth level of smartness, we call it autonomous, where we make a decision based on some rules, like smart grid and autonomous cars and stuff like that. So those are the 4 levels of smartness. Now let's look at some platforms, because some of the researchers ask, well, I have ideas, I have research in this, but I cannot implement it. So there are some platforms already can help you implement your project. The first platform, it's called ThinkWorks. It is actually specific, it has some specific functionalities designed for industrial IoT, like the connectivity, scalability, the security, and so on. Also, it is flexible, where you can actually deploy your product, or deploy your code, or deploy your information on a cloud, or even on your computer, or hybrid the cloud and your computer as well. You can use Microsoft Azure for that, and there are many other benefits for this platform. So this is the link for this platform, so if you want to try with it, play with this platform. There is another platform, it's called Embed. It's an open source. It is actually programmed using C++. It has its own online ID. You can optimize the code using ARM, C, or C++ compilers. And it has different stacks, like the networking, the storage, and drivers, and so on. There are thousands of examples over there you can try with. So this is another great development platform for IoT. Zivli is another remote access library. It's called the API. This is a library that you can use it with your either desktop or even the mobile applications, or the mobile, iOS or Android. So you can just import this library and work with it. If you want to connect to some devices and plug them in. There is another platform actually called AllJoy. It's a software platform. It is web-based, and this company, it's called One IoT tool. One IoT is the company itself, and it is a tool that enables users to create simple models using Internet of Things. If you are aware of or familiar with programming, web programming, so actually that will be the best framework for you. It's use JSON in each import or export or reading files and stuff like that. Also, it is compatible with RESTful architecture. So if you are familiar this will be a great tool for you. Intel Quark processor is actually designed. It's a microcontroller, and it's called System on a Chip. It's actually designed for IoT applications. So you have this one at your lab, or you buy it, that will be a great help as well. There are many others platforms like the AWS IoT, the Google Cloud IoT, the Microsoft Azure, SAP, Oracle, Cisco. So every big company has its own platform, IoT platform. So there is no reason to stop working on an IoT or to be afraid of implementing the IoT application or a system. So there are different platforms that you can use. Well, once we said that, let's dive into another part, which is the technical part, which is the IoT architecture. Let's see how many architectures are there. All this is machine-to-machine distributed architecture. As you can see, it's a three-layer architecture. At the bottom, there is the device domain, or the first layer. On the top of it, there is the network layer domain. Then, above that, there is the application domain. So this is what we call three-layer architecture. And at the bottom, if you can see the devices, it contains different devices, but this is limited to machine. So the guys here in this paper were talking about just connecting machines. And we consider machines as objects in IoT, so this could be considered as a distributed architecture for IoT. There is another architecture like this. We call it social IoT architecture. And the guys working on this paper, it's actually a three-layer architecture as well. So if you can see from the right to left, you can see here the objects, the gateway in the middle, and the application layer. And they include different things in each layer. For example, in the application layer, they said we have a network layer and application layer both together. I mean, the network layer, the application layer by itself includes different things like the base layer, the component sublayer, interface sublayer. And the network layer on the gateway, that means it has the internet, wireless LAN, cellular network, and different kinds of or types of wireless devices. The gateway has be considered that the gateway in the middle could have some actually optional components, like the application layer could be eliminated from the gateway itself. It can be considered as the a router in the middle. So also the sensing layer could be eliminated here. So this is another architecture for social IoT. This is another paper for architecture. This comes actually from one of the recent papers. The guys were talking about the future health IoT. So we have an architecture with 4 layers. The bottom layer is always the sensing layer. On the top of it is the communication, or the networking. Then they said we have a cloud computing, so they include the cloud computing as a separate layer on this architecture. Then at the top are the applications. Different type of applications, like as you can see, wireless sensor network, wireless friendly network, vehicle network, mobile communication network, and a part of this network, they say that we have a satellite network that communicate, or that means not that communicate or merge all of these networks together. So this is another architecture for the IoT. Well, if we come to the military, you see different things. So here's another IoT network. It is actually IoT architecture for military. As you can see, there are different layers. One of the layers actually the physical sensing layer and the gateway communication layer. Then it is called G4ISR management layer. It's a management layer. Then the application layer. So it is actually 4 layers. However, in each layer there are different components, so we try to include everything. In this architecture, we try to include every device we know and every protocol we know, because actually it is designed for military. So basically, we could have 3-layer application architecture, like the perception layer, network layer, application layer. And we could have maybe 5 layers, like perception layer, transport layer, processing layer, application layer, business layer as well. So this is another, what we call it, 5-layer architecture. This is an interesting architecture. It's called IoT and full computing architecture. We tried to include or involve the full architecture of the smart IoT gateway, of a smart IoT. That means we have a physical layer and we have a transport layer, and in the middle we have the fog layer. As you know, the fog layer, we have just a border that we need to build, which is the gateway. So this is actually, we put the gateway in the middle of this architecture. Also, we had a project, we call it I-Class. This is me and Professor Huggers. We built a smart classroom. It was at German University here, and we based our I-Class on 4-layer architecture, like the sensing layer, the internetwork layer, the data collection layer, and decision-making layer. And decision-making, the data collection layer, and internetwork and sensing, that's actually basic architectures that we saw are main components of any IoT architecture. But the decision-making layer was, we added the artificial intelligence, like we were using neural networks and fuzzy logic on this layer. Here are some of the devices that we installed or deployed in the classroom. As you can see, there's a weather station, there's external temperature, humidity, and light sensor. We have internal humidity sensor, internal temperature and light sensor. We have two presence sensors. We have Zigbee wireless sensor as well. And we have what is called lone server, and this is actually our web server and the data. And this is the box we created along with a board. It is called K8000 board. And we had, because we are talking about the intelligent classroom, we had an RFID tags and RFID reader. Out of this project, we tried to do many things. For example, we noticed that one presence sensor is not enough, so we put 2 presence sensors at the same time, so we confirm if somebody is in the class or not. Based on this I-Class, we tried to get an automatic attendance for students, but we faced different problems because of the culture. So every student will have an RFID, and the reader is connected to the internet and a database that contains all of the students. So when the students entered, this is actually a wireless reader. When the student enters the class, the reader will read that the student is already present and record its presence. However, we don't let the students get into the class, then after maybe 5 minutes will go out, that his attendance is there. So what we did, we turned the attendance recording every 5 minutes. So if the students went out, then he will be absent. Then when he comes back, we'll record his attendance, and later on we can count how many minutes a student was present at the class. But we had another problem, which is student come with two IDs, his ID and his friends, and put it in his pocket, and the reader will read both of them as they are attending. Or maybe they leave the card on the desk when they go out. So this is another problem that we faced. We tried to get the distance between the RFID cards, and some research is going on in this. Another thing, we adjust the classroom, the intelligent classroom was adjusted based on one profile. But what about multiple profiles? That means if all the students already in the class, so in which profile I adjust the temperature and adjust the light on the class. So this is another problem, a research problem that is going on. I don't know if we can stop and ask a question or not, but allow people to ask you questions.
Yes.
Can we stop and receive some questions, then we go back, or shall we continue until the end of the lecture? Okay, I'll continue. Then by the end we can answer any question. So based on this is another project that we talked about on the architecture. But there's another paper, actually a good paper. It shows the relationship between the IoT applications and infrastructure and its middleware requirements. Well, people talk about the architecture and the layers and stuff like that, but there is a middleware. This middleware is ignored in every architecture that I saw, but this paper found the middleware requirements. So for example, if you have functional requirements and IoT characteristics, the non-functional requirements are architectural requirements. So the guys in this paper detail what are the requirements for the middleware of IT. So there are different types of requirements, like the architectures, the architectural requirements, the non-functional requirements, and functional requirements. So this is a good paper. So if you are planning to work on this field, you need to read this paper. It gives you an idea how it works. Once we said different applications, different architectures, let's go for the challenges. Well, IoT challenges, there are different challenges. The first thing, we saw different architectures. We saw different devices. But everyone comes from a different vendor, and everyone works by its own. I mean, by his or her own. Even the guys like the Amazon and IBM and Cisco, they just go by themselves. So there is a problem in the standardization in most of the areas, not only in the devices, but actually in the protocols. Also, as you can see, that the innovation or the devices, there are rapid innovations and a challenge, and this is a challenge to keep up with for IoT devices. Another challenge, we are working with tiny devices like sensors. We're working with cell phones or mobile phones. Those devices are having rare or having small energy, like for some of the sensors are powered by AA batteries, and it's supposed to live for a long time. So the power and energy efficiency or optimization, it is another challenge. Also, as we said before, things to cloud, that means I'm connecting devices to the cloud, so there will be a communication between those devices and the cloud. Offloading, as we mentioned, is another problem. Big data analytics, this is a new term that and it's a hot topic as well. But if you look at it from the IoT perspective, you see like a smart home, for example. If there are different types of devices, and all of these devices collecting data, huge number of devices are there. What about if you go for a smart city? If you go for ad hoc vehicles, all of these devices will collect data, and these data need to be analyzed and a decision to be made. Another thing is virtualization. Well, I'm not talking about the cloud computing. If you are coming from the background of cloud computing, the virtualization term here is different. I mean, virtualization here means multiple sensors can be aggregated together, or a sensor shared by multiple users. We call this a virtualization. Also, the heterogeneity. Well, we have different devices, different vendors, different characteristics. So this is another issue, like the homogeneity or heterogeneity. There are some other issues like the technical, economic development, and social culture as well, legal, human rights, because some of the devices will be implanted in a human body. So this is another human right and legal issues. Well, but the most important challenge is the security in IoT device. As you can see, there are tiny devices that you cannot build the cryptography algorithms in it. It is not a computer. It's actually small, tiny devices with microcontroller. So you cannot develop or build the whole security system on such a device. So here's the best example you can watch. Imagine that you have a black hat that hacked into your toilet. That is, your toilet is connected to the internet, and somebody hacked into your toilet. So this is the security issues. Also, imagine that you are connecting a thermostat, and somebody hacked the thermostat and accessed it and control it. So this is another example on the security and the security vulnerabilities or threats. Actually, this is a fact. Like this thermostat the hacking or vulnerability is detected by Cisco Talos Group, and it took actually 12 months to publish fixes for just 2 vulnerabilities on this device, and it took actually 21 months to publish fix for 1 vulnerability for another vulnerability. So also another security challenge is you might not be aware of hacking. You don't have IDS to detect the hacking on these devices. So the security is actually a big challenge, and on the other hand, it opens a research on this area. So it's a hot topic, especially we have some actually malwares already hacking the IoT devices right now. So if we divide the security and look at the security in IoT, mainly the security has, as you know, has 3 main components: the authentication, integrity, and availability. The main attack on the IoT right now is the denial of service attack, along with the malwares in different actually layers of the architecture that we saw. So to summarize the IoT challenges, we can say we have technical control challenge, we have data analysis, social ethics, legal, standards, security, and heterogeneity. Those summarize the IoT challenges. But is there any opportunity for IoT? Yes. Of course, we have opportunities. There are 3 core sectors of IT: enterprise, home, and government. Well, the enterprise is the most actually opportunity that we have for individuals. So you can start your own company working in IT devices. For example, in 2019, the electronic IoT sector was estimated to account for nearly 9.1 billion devices. So there's an opportunity for individuals or enterprises to work in this field. However, the government has to go also with this, with IoT approaches or IoT technology, because it's emerging technology and it's coming anyway. But now we talked about the IoT. We didn't talk about the intelligence yet. Where is the intelligence? Well, let's see. Let's define first the intelligence before we go into IoT and intelligent IoT. If we define the intelligence, Stephen Hawking defined the intelligence as is the ability of a system to adjust appropriately to a changing world. There is another definition by Socrates. He said, I know that I'm intelligent because I know that I know nothing. So this is another definition for intelligence. I went to Webster Dictionary and looked up the intelligence, the word intelligence. It says the ability to learn or understand or to deal with the new trying situations or reason. However, we have different, as an Arab world, we have different actually definition to intelligence. So you might notice that some guys is announcing turn your Android into iPhone X. This is intelligence, 15 minutes. So this is another type of intelligence. It's actually people intelligence. But I came up with one definition, and this is actually associated with Liverpool because I developed a course for them about the intelligence system. So this actually term, I put it in the course, so just the rights, just to give them credit. Intelligence is the ability to learn, understand, think, and reason. So this actually summarizes the term intelligence: ability to learn, understand, think, and reason. And if we look at the fields of artificial intelligence, we can see that we have machine learning, natural language processing, speech expert systems, robotics, vision, planning, scheduling, optimization, and there are some other fields, subfields of the artificial intelligence. I have a video for Mark Cross, but I don't know how can I share it with you. Let's end the show, then we go to the video. I'll share. Okay, just a second. Okay.
We've all heard the increasingly used trendy term, the Internet of Things, and how game-changing it's going.
Is I connected or something? Okay. Well, we cannot find it as an application, so. Okay.
To be as we extend. We've all heard the increasingly used trendy term, the Internet of Things, and how game-changing it's going to be as we extend sensors, miniature sensors, into everyday objects. Everyday objects will start to give us real-time feedback, and the world essentially will come alive. This is the Internet of Things. What if we evolve the term a little further? What if instead of the Internet of Things, we enter the realm of the intelligence of things? The intelligence of things is where the Internet of Things meets artificial intelligence. Because the future of artificial intelligence is senseless unless we extend it into the world of everyday objects. This idea that as we impregnate intelligence into the world of physical things that we inhabit, the world essentially will come alive. This real-time feedback, this interface that will become enlivened with intelligence will essentially will birth a world that will increasingly talk back to us. Now, how this will change human subjectivity, how this will change the human condition, space of mind in which we dwell, is in the following way. Increasingly, we'll dovetail our minds to the world, right? And as the world starts talking back, the distinction between self and world will start to disappear. The external space, the external world, will increasingly start to feel like an extension of our mind, like an extension of our agency, which will bleed over into a world of predictability, a world that will know what we want before we want it, a world of serendipity, a world in which you look for something, you find something else, and you realize that what you found was more conducive to your needs than what you thought you were looking for. We're talking about a world optimized for human creativity and human enterprise, a world that is responsive, a world that is alive, a world that is intelligent. As I imagine, so it becomes, and this is the very essence of magic. Now, you're pumping all this data, you're pumping all this AI into sensors, into the world of everyday objects, and again, you birth the world, the intelligence of things. The mind will have fully turned itself inside out. We will be inhabiting the condensation of human imagination. The nodes in our brain, the neurons will have spilled out into the world. We will cloak the planet in mind and data. This, my friend, is a singularity of mind and meaning. When everything becomes linked with everything else, matter becomes mind. This is intelligence of things.
Okay. So this guy is a little bit crazy, but he defines actually the intelligence of Internet of Things. I still have some slides, but I might stop here just to maybe I'll complete the lecture after all in another session because of the time. Because we promised to stop at 10, so it's almost 10. So I might go for another session, inshallah. So thank you so much for your patience and kind. So I don't know if I can receive questions or not.
جزاك الله خير يا دكتور. نفتح الباب للأسئلة. في ناس كانت عاوزة بعض الأسئلة باللغة العربية.
I need to register your email. Sure. Here is my email. That emailing, and if somebody needs to communicate with me, you are more than welcome.
إذا في حد عنده سؤال ممكن يتفضل. If you have any question, please ask.
Okay. تفضل يا رب. شكرا لك. ربنا يكرمك. كان على صيانة الIT ده اللي احنا كنا بنتكلم عليه، ان احنا عندنا opportunities في عندنا opportunities في enterprise ان احنا نشتغل على ال IoT devices سواء كان في السيلينج او في الصيانة. فمع انتشار ال IoT اكيد هيبقى عندنا مستقبل في صيانة ال IoT بصفة عامة، سواء كانت السنسورز، الكاميرز، الكونكتيفيتي، السوفت وير، اكيد هيبقى عندنا حاجة زي كده. السؤال الثاني ازاي الذكاء الاصطناعي بيساهم في ال IoT من اي ناحية؟ احنا يعني لو احنا شلنا الذكاء الاصطناعي من ال IoT هتبقى هوم اوتوميشن او يعني اوتوميشن بصفة عامة. اوتوميشن يعني ايه؟ يعني انا بس بعمل تحكم على بعض الديفايسز، على بعض الاجهزة اللي عندي في البيت او في الشغل او في اي مكان. لكن لما بضيف ال artificial intelligence انا بعمل analysis، باخد decision. زي ما شفنا بعض السيستمز اللي هو مثلا زي ما كنا بنتكلم على كلاس روم، انا بعمل بروفايلنج كلاس، انا عايز يعني اعمل بيسموها ايه adjust الكلاس روم من ناحيه التمبريتشر والبورد والليكتشرز وحتى اللايتنج، الشبابيك اللي عندي وما الى ذلك. طيب يا ترى انا هعمل ده مانيوال ولا هو يبقى اوتوماتيك؟ طيب لو انا هعمله اوتوماتيك يبقى مش مجرد ان انا ادخل مثلا الكلاس يفتح لي الويندو والكلام، لا ده لازم يكون عنده بعض الهيستوري وياخد ديسيجن بيست على هذا الاساس. عندي بعض التكنيكس اللي ممكن استخدمها في الارتفيشال انتليجنس ان انا ادرس الهيستوري بتاع الستودنتس اللي كانوا موجودين في الكلاس، their interest and so on، كل بروفايل لوحده مثلا، وبعدين اخد الديسيجن اللي يناسب كل الناس. ده مثال بسيط يعني على استخدام الارتفيشال انتليجنس. هل الاردوينو؟ طبعا اكيد الاردوينو راسبي باي من المايكرو كنترولرز الجديده، او يعني الاردوينو بقى له فتره، لكن راسبي باي مور ادفانسد دلوقتي ورخيص جدا. حتى احنا شغالين على بروجكت اللي هو التراكنج سيستم، بنعمل سمارت تراكنج سيستم مش بس التراكنج سيستم، بنستخدم فيه الاردوينو. What adaptability with existing devices? I think this issue for many to replace their existing machines for IoT, there is solution. Well, هي طبعا انت بتتكلم على لو في already devices موجودة وعندنا مشكلة في الريبليسمنت بتاعها، او ان احنا نكونكت نكونكت الاي تي systems يعني. طبعا دي حتى في الكمبيوترات العادية موجودة، ان يكون عندك كمبيوتر قديم وبعدين وصلت I don't know if you speak Arabic and English هيثم؟ طيب فأكيد عندنا نفس المشكلة في الكمبيوترز القديمة. لما تيجي تنزل عليها ويندوز محتاج محتاج تابجريد السيستم and so on. لكن للأسف مش كل الديفايسز ممكن تشتغل على النيو تكنولوجي يعني. فده محتاج يا إما replacement يا إما adaptability بسيط لو بتنزل سوفت وير ولا حاجة عليه. لكن it's a problem أكيد. It's a problem. We need solution. I don't have actually a ready-made solution for that. HTTP and the QTT ما فرق بينهم. طيب احنا عندنا بس لان احنا بنستخدم different techniques. ال HTTP بيستخدم على مستوى الويب سايت، يعني الكوميونيكيشن لان انت للبراوزنج بصفة عامة. لكن ال MQTT I believe ان احنا بنستخدم different protocol في sending و receiving بين ال IT device، لان انت عندنا مشكلة كبيرة في انت في البروتوكول بتاع ال HTTP انت بتسند مسج سايز معينة، الهيدر بتاعها معين، الباك اند او الترمينيتور بتاعها معين بسايز معين. ال IoT devices small devices ما تقدرش تبني actually كل اللايرز والستاك بتاعت مثلا الموبايل بتاعك او الكمبيوتر اللي يقدر يبعت الرسائل دي كلها. فبالتالي ده different architecture للمسجز والستراكشر في الكوميونيكيشن ما بين الديفايسز. ممكن كمان المرة الجاية لو عندنا ليكتشر ثانية ممكن go deeply into the two protocols.
شكرا جزيلا دكتور في سؤال بس، ازاي ممكن نعمل شير للسلايدز؟
طيب I'll put it in my website and share it with you, no problem. يعني هحطها على الويب سايت بتاعي وبعدين شيرت مع حضراتكم، يعني مفيش مشكلة.
جزاك الله خير.
جزاكم الله خير. شكرا لحضراتكم جميعا يعني، وشكرا لحسن استماعكم.
شكرا.
مع السلامة.
شكرا لك يا دكتور، يعطيك العافية.
الله يكرمك، شكرا لحضرتك.